When studying the reflection of light, it's important to have a way to predict the nature of images formed in mirrors. What do I mean by this? If you take a mirror and look into it, you see yourself a certain distance away. But plane or flat mirrors are a bit basic for this level. We're going to look at a way to make predictions for curved mirrors. It's a geometric method called a ray diagram, and for this video, I will demonstrate it using a convex mirror. This is the first step of a ray diagram. Draw the diagram without any rays. What I have here are two black lines at right angles to each other. Where they meet is the center of the mirror, which I've drawn in red. The stickman on the left is our object. Objects are often represented by a vertical arrow on these diagrams. Notice that the mirror bulges out toward him. That's how we know it's convex. There are a few words we need to get used to. The horizontal line is called the principal axis, or just the axis. The whole diagram is laid out along it. The vertical line is called the pole of the mirror. It's the line where reflection actually takes place. You'll see the full significance of it soon. The distance between this pole and the object, labeled DO, is simply the object's distance. The point on the right, labeled F, is the focus of the mirror, while C represents the center of curvature. If this mirror were part of a large sphere, like a soccer ball, that sphere would be centered on C. Note that the focus is exactly halfway between C and the pole. Now we can get started. We can draw two light rays that come from the top of the object, so off the stickman's head, and strike the mirror. The first of these rays comes in parallel to the axis, like this. It hits the pole and reflects. How do we know where it reflects to? Draw a dotted line connecting the end of the incident ray with the focus. The reflected ray has the same slope as this dotted line and goes like this. It's reflected so that it appears to have come from the focus, from behind the mirror. When we find the image, you'll see why this is such a big deal. The second ray we can draw comes in toward the focus like this. Again, it comes from the stickman's head, but instead of being parallel to the axis, it's like an arrow aimed right at F. It hits the pole of the mirror and reflects parallel. In toward the focus, out parallel to the axis. It's like the opposite of the first ray we drew. Now, can you guess where the image will be? For an image to form, we need light rays that converge on a point, but these rays aren't converging. They're just drifting away from each other. This is where that dotted line comes in, because we can trace the second reflected ray back, like this. The dotted lines represent virtual rays. They're virtual because they're behind the mirror. Now there's a point where they converge, and that's where the head of the image will appear. Our friend's image is a lot smaller than his. In physics terms, we say it is diminished. The image must fit in that little gap between the virtual rays and the axis. It's also upright because it's standing the right way up. We also say this image is virtual. Fair enough, we used virtual rays to locate it. But what does virtual actually mean? It means that the image is behind the mirror, but if our stickman really was back there, we wouldn't be able to see him because the mirror only reflects on one side. It's a common sort of optical illusion. Here are some key things to remember. First of all, you always get a virtual image with a convex mirror. It doesn't matter where the object is, as long as it's in front of the mirror, or where F is or how wide the mirror is, you always get a virtual image, as opposed to a real one which can be projected onto a screen. To draw a ray diagram, first draw an incident ray that comes in parallel to the axis. It reflects so that it goes directly away from F, the focus. Then, draw a ray aiming at F so that it reflects and goes out parallel to the axis. Trace the reflected rays back as virtual rays. Where they cross is where you get the image. Reflection happens at the mirror's pole, not the mirror itself. We draw mirrors on these diagrams only to tell you whether you're dealing with a convex or a concave one. They aren't drawn to scale. Finally, the most important rule of all, use a ruler. Humans did not evolve to draw perfectly straight lines, so you need a ruler to draw an accurate diagram. I recommend that you go now and practice making ray diagrams, as they may help with the next set of questions about curved mirrors. Good luck.